This is activity 1, equation talk for lesson 5, solving any linear equation. So any linear equation as we go through this. So for activity 1, you're given 4 equations and you're just simply supposed to talk through how you solve them. So how would you mentally find the value of x in each case? And I'm going to write some things out to show you how I would think about these. The first thing I want to say, though, is the first 2 problems have to do with addition, and the second 2 problems have to do with multiplication. And I'm going to explain in a little while why I only say addition, and I don't say addition and subtraction, and I only say multiplication, I don't say multiplication and division, because any subtraction problem can be rewritten as an addition problem because they are inverse operations, and any division problem can be rewritten as a multiplication problem because they are inverse operations. So we'll get to that in a little while. But if you look at this first equation, you're going to move terms back and forth across this equal sign to get all of the x's, in this case it's a single x, on one side and all of the numbers on the other side. So there's lots of ways to do this, lots of ways to think about it. What I want to do first, though, is rewrite this as this is 5 minus a positive x. And I'm going to rewrite this as 5 plus a negative x. So I'm going to rewrite that subtraction as addition. Once I do that, I can move this negative x over to the other side by adding a positive x to that. So notice it changes signs because the way that you've gotten this x to the other side, to the right side of the equation, is you added a positive x. So this goes to 0, and that positive x shows up on this side. So it's as if you're taking this negative x, and as you go across the equal sign, it changes signs. Well, the reason it changes signs is you are in fact adding a positive x on this side. So let's look at this in a little bit more detail. So this is a positive 5 plus a negative x, so plus a negative x equals positive 8. So I'm going to move this 8 to the left side. And as I move it to the left side, this is going to take on a negative 8, because how am I getting it over there? I'm adding the additive inverse, which is a negative 8, to get rid of this positive 8, and so that 8 shows up on this side as a negative 8. So once you do that, you're going to add these together, you subtract their absolute values, so 8 minus 5 is 3, and since there are more negatives, it's going to be a negative 3. So let's try this again. Instead of moving the 8 to the left, let's move the 5 to the right. Well, it's the same idea. You're going to add the additive inverse of a positive 5, which is a negative 5. So it's going to show up on this side as negative 5. It's going to disappear from here because a positive 5 plus a negative 5 is 0. So now you have negative x equals positive 3. Over here you had, actually have everything on the same side. All right, so let's think about what's going on. So if it's the same sign, if the numbers or the terms have the same sign and you're moving one to the other side of the equal sign, you're going to take the difference of the absolute values because they're going to change signs. So these are both positive, but as you move this over here, it becomes a negative 8. So the difference of the absolute values is 8 minus 5 is 3. It's going to be a negative 3. Over here, it's a positive 5. It's going to be negative 5. 8 minus 5 is 3. But in this case, it's going to be a positive 3 because there's more positives. So when you have the same sign on each side of the equal sign, you're going to deal with the difference of the absolute values. It gets hard to think about, talk about, just different ways to look at it. So try to come up with your own way of thinking about it, but try to understand what's going on. So here it is, positive 5 plus negative x equals positive 8. This positive 8 is going to go to this side, so it becomes negative 8, because the way you've gotten rid of it is you've added a negative 8 here and added a negative 8 here. The difference of their absolute values, 8 minus 5 is 3. It's negative 3 because there's more negatives. So now we have a negative 3 plus negative x equals 0. So now you add a positive x to both sides. So this negative x goes over here, and it becomes positive x because you've added a positive x, the additive inverse to get rid of this negative x. You have to do the same thing over here. So this is a positive x equals negative 3, so x equals negative 3. Now if we decide to work up here and deal with the 5 moving over to the right side, you have to still get x equals negative 3 because x does equal negative 3. So I'm going to move the 5 over here. So I'm going to add a negative 5. So this shows up on the right side as a negative 5. What's the difference of their absolute values? 8 minus 5 is 3. But in this case, it's positive 3 because there's more positives than negatives. So now we're left with negative x equals positive 3. So say that in words, the opposite of x equals positive 3. So that means that x has to equal negative 3. I'll say that again. The opposite of x equals positive 3. So that means that x has to equal negative 3. The opposite of a negative 3 equals a positive 3. Now the way to change that sign mathematically is to multiply through by negative 1. So the opposite of a negative x is a positive x, and the opposite of a positive 3 is a negative 3. So x equals negative 3, x equals negative 3. So to get another idea of what's going on, let's put this on a number line. So this is 5 minus x, and I'm going to rewrite that as 5 plus a negative x. Well, how do you move to the right? So you're moving from 5, you're adding a value, a negative, the opposite of whatever the value of x is, and you're ending up moving farther to the right. So what does that tell you about this x right here? And that x has to be, you're going to have to add a positive. So this whole thing has to be positive. So this is the opposite of x, is a positive value. So the opposite of x, so the opposite of x is positive. That means that x has to be, and this is hard, it takes a while to kind of think through this, x has to be negative. So the opposite of a negative value is positive, and you're going to add a positive value to 5 to get to 8, and it's going to be a positive 3. So x equals negative 3, we know that from before. So the opposite of negative 3, the opposite of negative 3 is a positive 3. The opposite of negative 3 is a positive 3. So positive 5 plus the opposite of negative 3 equals positive 8. Well, the opposite of negative 3 is a positive 3. So positive 5 plus a positive 3 equals positive 8. Now, if you didn't make this change, if you left this as a positive 5 minus x equals 8, and replace this x with negative 3, you'd get 5 minus a negative 3 equals 8. And you probably remember the rule of if you're going to subtract negatives, that's the same as adding positives. And mathematically what that means, and it's no different than what I'm doing up here, is it means subtracting a negative 3 is the same as adding its additive inverse. What's the additive inverse of a negative 3? It is positive 3. So 5 plus a positive 3 equals 8. This is a lot, and just lots of little details to think about. I would listen to the video a number of times and talk through it with somebody and see if you can develop your own understanding of what's going on. This is the second problem, which says negative 1 is equal to x minus 2. So I'm going to change this x minus 2 to x plus a negative 2. And so notice that the sign of the integers, or the sign of the numbers, is the same. It's both negatives. So as you move, or if you get rid of one of the negatives on one side, you're going to end up finding the difference of the absolute values on the other side. So in the first case, if we get rid of this negative 2 by adding its additive inverse, positive 2, that means that on the other side, the left side, we're going to have negative 1 plus positive 2. What's the difference of those absolute values? Well, 2 minus 1 is 1, and it's going to be, the answer is going to be positive because there's more positives. There's 2 positives and only one negative. So x equals positive 1. On the other hand, if we choose to get rid of the negative 1 on the left side, we're going to add the additive inverse of negative 1, which is positive 1. This becomes 0, and you have a negative 2 plus a positive 1. What's the difference of their absolute values? 2 minus 1 is 1, but in this case, it's a negative 1 because there are more negatives. So on this side, we have a negative x equals negative 1 because we add the additive inverse of a positive x, which is negative x, to get rid of this, and you're left with negative x on the left side. So if you say this in words, the opposite of x is equal to the opposite of 1. The opposite of x is equal to the opposite of 1. That means that x equals a positive 1. So right here, mathematically, the opposite of a negative x, so the opposite of a negative x, I'm multiplying this side by negative 1, and I'm multiplying this side by negative 1. So the opposite of a negative x is x equals the opposite of a negative 1, which is 1. So x equals a positive 1. Working with positive and negative numbers is tough. You have to slowly work through the problems and keep track of what the signs are. So what is this showing you on a number line? You're starting at x, you're adding 2 negatives, or you're subtracting 2 positives, but adding 2 negatives is the same thing. That means you're moving to the left. You're moving 2 units from the left from some value over here, and you're ending up at negative 1. So to figure out what that value is, you could just add 2 units to negative 1. So it'd be 1, 2, and you'd end up with positive 1. So you're at positive 1, you add 2 units, 1 unit, 2 units, you end up at negative 1. So x is equal to positive 1 plus a negative 2 is equal to negative 1. Just these simple little numbers. They're tough because the signs change. You have to keep track of what you're doing. Try to think through it mathematically, make it make sense rather than trying to memorize rules. For the first 2 problems, we used addition and the additive inverse to move terms from one side to the other side. So the first thing I did is I changed the subtraction of a positive x to adding a negative x, and the subtraction of a positive 2 to adding a negative 2. Those are the same things. It's just using the additive inverse and the inverse operation. So now we can move terms around. We can add the additive inverse of a positive 5, which is a negative 5. So that negative 5 is going to show up on the other side, and this is going to become 0. 5 plus negative 5 is 0, for example. We can remove the 8 on this side, and it shows up on the other side as a negative 8 because we're adding negative 8. Or move this x to this side, it's going to show up as a positive x because we're adding a positive x plus this negative x to make this 0. Same for number 2. We can move this negative 1 or remove this negative 1 by adding a positive 1. That means a positive 1 is going to show up on this side. Add a negative 2. Add a positive 2 because this is negative 2 right here. Add positive 2. That means a positive 2 is going to end up on this side. If we want to move the x over here, add a negative x. That means the negative x is going to show up on this side. So we're moving terms on the other side of the equal sign, the other side of the equation, by using additive inverses. For the last 2 problems, we're going to use multiplication and the multiplicative inverse. And before we use the multiplicative inverse, and I'll go into that in a few minutes, I'm just going to show you that you can reason through what these answers are. So this is negative 3 times some number equals 9. Well, you know that 3 times 3 equals 9. So the opposite, negative 3, the opposite of 3 times 3 would be a negative 9. So the opposite of 3 times a negative 3, so 3 times a negative 3 is negative 9. The opposite of that is a positive 9. And you can actually factor out the negative 1. Negative 1 times 3 times negative 1 times 3. Then the opposite of negative 1 is positive 1. So those 2 negative 1s multiply together, become a positive 1, and you're left with 3 times 3 is 9. This takes a little bit of practice. The next one, you know that 2 times 5 is 10, so this is 2, x is going to be 2, either a positive or negative 2. And you multiply it by this negative 5, you get negative 10, so this is 2 times negative 5. 2 negative 5s equal negative 10. So once again, you know that 5 times 2 is 10, so a negative 5 times that same positive 2 is a negative 10. It's the opposite of 5 times 2. So x is a positive 2. So we remove the coefficient, but notice that x, that variable, stays on the same side of the equation. Up here, we're moving things back and forth, and you can even move the x's back and forth. Here, these two, that x stays on the same side, and you just get rid of the coefficient. All right, so for this problem, this is a negative 3x equals 9. So x is what value? So I know that negative 3x equals 9, and I want, if I have a negative 3x's, I want a negative 1/3 of those negative 3x's. I want to multiply by the multiplicative inverse. So a negative 1 over a negative 3, let's say it that way. 1 over a negative 3 times negative 3. So it's basically 1/3 of negative 3, but it's the opposite of that. So these negative 3's cancel out. Negative 3 divided by negative 3 is 1. So you're left with 1x, but you have to take the same fraction of 9. You have to take a 1 over a negative 3, or a negative 1/3 of 9. Well, this is negative 3 over negative 3, and you can cancel out, or I'm sorry, you can factor out these negatives. So this could be negative 1 times 3 over negative 1 times 3. The negative 1's divide, they cancel, they equal 1, and 3 divided by 3 cancels, that equals 1, so you're left with x. On this side, you have 9 over negative 3. And you can factor the 9 to 3 times 3. So now you have 3 over negative 1 times 3 over 3. These 3's cancel. And this takes some practice to go through this. You're just going to do this automatically pretty soon. You'll see how to do it. You write the factors. You'll cancel the factors. So you're left with 1x equals 3 over negative 1. That's the same as the opposite of 3 over 1. So x equals negative 3. 3 divided by 1 is 3. And it's a negative 3 in this case. This takes a while to get used to. This 3 over negative 1 right here can be written in several different ways. You can look at this as a negative 3 over 1, so that negative sign can be written as the whole fraction as a negative, or the numerator can be written as the negative, negative 3 over 1, or 3 over a negative 1. And all of those are equal to negative 3. And I think probably the best way to look at this, the way that makes the most sense to me, is look at this as a factor of negative 1 over 1 times 3 over 1. I should have written that here, negative 1 over 1 times 3 over 1. And then you can look at it as a negative 1 times 3 over 1, which would be this one. Or you can look at it as 1 times 3 over negative 1, which would be this one. Or a negative 1 times 3 over 1, which would be this one up here, which then simplifies to this. So several different ways to view this. And I think the thing to remember is that if you have a negative fraction, even this fraction right here, this could be written as a negative 9/3. It can be written as a negative 9 over 3, or it can be written as it is, as 9 over negative 3. So you can write fractions, negative fractions. You can place that negative sign in 3 different places. And I think, again, factoring out the negative 1 and writing it as negative 1 over 1, so negative 1 over 1, and then deciding where you want to multiply, which do you want to multiply by the negative 1, the numerator, the denominator, or look at the whole thing as a negative. This takes a while to get used to. Okay, so remember, we have gotten rid of the coefficient. This negative 3 by multiplying by 1 over negative 3. But notice that the x, the variable, stays on the same side of the equation. It does not move. It stays on the left side, and we're figuring out what that x equals after we've gotten all the terms. If there were some numbers added to this, we'd collect all of those terms and have a number on the right side, and that's equal to a coefficient times the variable on the other side, and then you have to get rid of that coefficient. So let's do this one more time. So in this problem, this is negative 10 is equal to negative 5x. And so we're going to multiply this negative 5 by its multiplicative inverse to get this to equal 1x. And then 1x is the same as x. So x equals whatever ends up being on the left side. Well, if you have negative 5, the multiplicative inverse of a negative 5 is 1 over a negative 5. So this is 1 over negative 5 times negative 5. So these negative 5s will cancel out. They will equal this 1x here, which then can be rewritten as x. On the left side, you have to do the same thing. 1 over negative 5 times negative 10. And it gets tricky working with negative numbers, and you just have to practice doing this. And so this can become negative 10 divided by negative 5. This is negative 5 divided by negative 5. So that all cancels. That equals 1. So that's going to equal x. On this side, you can factor out this negative 1. Negative 1 times 10, or negative 1 times 5 times 2. And on the bottom, the denominator, negative 1 times 5. So negative 1 times 5. The negative 1s cancel. Negative 1 divided by negative 1 is 1. 5 divided by 5 is 1. And you're left with 2. 2 is equal to x. Now I actually like looking at this up here as a negative 1/5 of negative 5. Rather than saying 1 over negative 5, I like looking at it as the fraction. I have 5 things here, so I want 1/5 of those 5 things, and it's a negative 1/5 of that negative 5. So I like saying this as a negative 1/5 of 5, negative 5, sorry, even though it's easier to see by writing it and saying it as 1 over negative 5. I like to think of it as a negative 1/5 of negative 5. So this would be a negative 1/5 of negative 10. So negative 1/5 of negative 10 is 1/5 of negative 10, which is negative 2, and then the opposite of that, which is a positive 2. So I would try different ways of thinking about it, saying it, and you will come up with a way that's comfortable.